Dear participants, please take your seats, join us. Good afternoon, everyone. We are going to start our event. My name is Vasilina Belyo. I'm head of climate department at NGO EcoAction. Today, I have an honor to moderate the panel with our distinguished authors of the climate damage report, who have been working for years to present today the 3 years of full damage assessment of Russian invasion. So for this panel, I am happy to introduce and invite Mr. Leonard de Klerk, lead author, Initiative on GHG Accounting of War, Dr. Swietlana Krakowska, distinguished Ukrainian climatologist, IPCC author, and author of this report as well, and Mr. Mikola Шлапак, specialist in environmental protection, greenhouse gas emissions accounting and climate policy, IPCC author, and distinguished author of this report as well. The goal of this session is to understand better what and how our experts are calculating, what remains uncertain, and why these insights matter, especially for holding Russia accountable. But before going with questions to our experts, I just want to make a quick overview of where we stand with the research. Do we have a clicker? We don't have a clicker. Let's start our presentation. I'll say a few words about how the initiative originated at first place. Not long ago, after the start of the full-scale invasion, there were leaders who decided to calculate climate damage for the Russian invasion. And this initiative is going on so far. So we already have 5 reports and a separate guidance on the measurement of GHG emissions, which we presented previous year at COP in Baku. Today, we will focus our attention on the climate damage for 3 years on the last report you can see on this slide. I should mention that this work would not be possible without the support of our donors. The 5th report we managed to prepare with the support of European Climate Foundation and Swedish Society for Nature Conservation. Our initiative is not standing alone by itself. We also have a governmental support, and this is a very big step to make ahead. So before deep diving into specific sectors with our speakers, let's see the main numbers of the war emissions. So currently, the leading sector responsible for the GHG emissions is warfare activities. The next one is reconstruction, followed by landscape fires with 21 responsible percent. And what we see here on this slide is the distribution of emissions through 3 first years of the full-scale invasion. Again, leading with warfare, followed by reconstruction, with increasing level of emissions from the civil aviation and energy infrastructure. Could you please get back to the previous slide? You can see how gradually emissions are increasing, starting with, on the first year was 120 million tons CO2 equivalent, then followed on the second year was 175, tons, 175 million tons of CO2 emissions. And currently we have almost 237 million tons of CO2 emissions. And on this slide, we can see the dynamics, how the warfare emissions are steadily increasing and the reconstruction emissions are decreasing. Landscape fires, also fluctuating, are increasing as well. Refugee emissions decreasing and civil aviation increasing. I will stop on that and will invite our distinguished authors to join the panel and tell us in more details what these numbers stand for and how they were calculated. So, Mr. Mikola, I'll ask you to take the floor and explain to the audience what warfare activities are measured, what are the main challenges and key findings in the calculations of this sector.
Thank you. Let's go to the next slide, please. Yeah, next slide. Yeah, so as Vasilina said, this is our fifth report already. And we were like continuously improving and expanding the scope and improving the methods of GHG emission accounting. And if you looked at this graph, you will see that basically fossil fuels are the most significant contributors to the warfare emissions. As Svetlana often reiterates, this is the fossil fuel war because it's from the one hand financed by the revenues from fossil fuels, but also on the battlefield is like fossil fuels is the engine of the war and the key source of GHG emissions. If you think what is the largest consumer of the fossil fuels like diesel and gasoline and jet fuel, you may think about the tanks or other large equipment, but the analysis revealed that actually this fighting tools like the key military equipment consume large volumes of fossil fuels, but even larger volumes are associated with the so-called logistic tail of the armed forces, because you need to transport all the like soldiers, equipment, ammunition to the front line, and further like behind the front lines, and this requires 1,000 tons of diesel fuel and other fossil fuels to power this the needs of their armed forces. In general, for GHG, the general concept of GHG emission accounting is pretty simple. You need the activity data and multiply them by emission factors. But in practice, it could be very problematic, especially for the accounting of warfare emissions, to find both the appropriate activity data and also the appropriate emission factors. So for the fossil fuels, the emission factors are like the easy part because we use the IPCC, the same emission factors that they used in the national GHG emission inventories. But for the activity data, it's very hard to collect data on the volumes of diesel and other fuels used on the battlefield. That's why we use like different approaches, including the increase in supply of fuels by railway to the regions bordering Ukraine at the first years of war, but also the estimates from previous conflicts and the average values were used in the reported results. Also, we have here ammunition. For ammunition, which mainly includes artillery shells, there are different types of emissions. So there are emissions on the battlefield at point of firing and at the point of impacts. But those emissions are actually very small and contribute only like 2% from the total emissions related to ammunition. The rest, like 98% of emissions, are associated with the manufacturing of ammunition. So the larger the amount of ammunition used on the battlefield, the larger would be the climate damage from warfare. And for ammunition, it depends also on the type of use of different ammunition on the battlefield. And there are two important characteristics, like the firepower of the army and the precision of the ammunition. And especially at the beginning of the war, Russian forces relied significantly on this firepower to compensate lack of precision capabilities. And up to 50,000, 60,000 of shells were fired per day in Ukraine and caused large-scale destruction at the beginning of the war. And this caused significant emissions associated with the manufacturing of ammunition. We also have here equipment, which is like military equipment, like tanks, armed forces, different armed carriers, and other types of military equipment. And this is large equipment made from steel, which is very carbon intensive material. That's why it's also causes significant emissions. Here, like open source intelligent enthusiasts are doing very significant work in tracking the losses of different types of military equipment. And that's why the activity data are quite reliable, but still not all losses are tracked. So there is a correction factor used to account for those losses that are not visually confirmed. But for the emission factor, then there are not much studies focused on life cycle emissions of the military equipment. That's why we used studies on civil equipment such as construction machinery or agricultural machinery as the proxy to estimate climate damage from the destruction of military equipment. And lastly, we have the fortifications, because they require significant volumes of concrete, which is very carbon intensive to manufacture. At the beginning of the war, where the front lines were moving very actively, there were no large-scale construction of fortifications, but later, when the front lines were more stable, both Russian forces and Ukrainian armed forces constructed like layered fortifications. Some of them are visible from satellite images and could be, at least to some extent, estimated the amount of concrete used, but other are not visible because it's like the main purpose of fortification structures to also to protect and the soldiers and other important locations, and that's why they are like also being covered, not to be detected by drones and other civilians methods. But yeah, so in general, warfare emissions is mainly from fossil fuels, but other parts are also like ammunition, equipment, and fortification. Let's go to the next slide. And this is just the interesting aspect of this war, because during the like almost 4 years of war, there was significant development and increase in scale of use of different types of drones. But if you see the total values for emissions from ammunition, they were decreasing during the 3 years because of the decline in stocks of ammunition. During the first year of war, this large-scale use of ammunition resulted in the fact that there was like a deficit of artillery shells, and our armed forces were looking to other alternatives, and then drones were evolving rapidly. But this decrease in emissions from ammunition are actually compensated with the increased emissions from the destruction of military equipment, because drones like have better like kill rate, so they are more precise, and the like success rate of attacks by drones are much more higher compared to the like kill ratio of regular artillery shells. That's why we see the significant increase from year 2 to year 3 in emissions from military equipment, and in total we would have approximately the same number of emission, 1.7 millions, if we combine use of ammunition and military equipment for year 2 and year 3. Let's go next to the next slide. And the other aspect that we've covered in the report is GNG emissions associated with the energy infrastructure. There is a big part related to large-scale events, which include the destruction of Nord Stream pipelines, which is the most significant single event that caused the most significant methane emissions, but also the attacks on the oil and gas production infrastructure on the Black Sea. We also have significant emissions from attacks on oil depots and refineries. From the first days of the war, there were large number of missile attacks on the oil depots in Ukraine, which resulted in large fires and large volumes of fuel burned and emissions generated. Later in the war, we've seen continuous attacks on oil infrastructure, both in Ukraine, but also in Russia, because of the evolving strike capabilities of Ukrainian defense forces. And this category of emissions will continue increasing, because if you follow the news, you would see the almost like each week or even more often the information about the attacks on oil infrastructure and oil refineries during this year of the war. So for the fourth year, it will be also a very significant source of emissions. This is done like to undermine the capabilities of Russian forces to fuel this war, both in terms like directly, because armed forces require significant volumes of fuel, but also indirectly, because revenues from oil sales finance the aggression against Ukraine. And the last is to highlight is SF6 emissions. During the first year of war, as you see, there is a very large scale of these emissions, and this is because of the attacks on high voltage electricity transmission infrastructure, which resulted in very extensive damage of transformers and other equipment on the substations in Ukraine, and resulted in blackouts in Ukraine. And But for the second and third year, reported emissions are lower, but this is also partly because of lack of sufficient data on the destruction of equipment and related SF6 emissions. And smaller amount is onshore gas production infrastructure, which basically in every village or town, city on the front line or in other regions that were under attack, you will often see the destruction of gas pipelines in residential buildings or in other locations, or gas transportation within the gas transportation network. And all this could result in both in CO2 emissions from the fires, but also from in methane emissions due to the leakages after the damage of pipelines. Here, activity data are not currently reliable, but Ukraine actually implemented the procedure to collect data from like damage of gas infrastructure and loss of natural gas due to the war. So after the war, this data could be available. To sum up, I would say that we need both like additional research on the emission factors related to warfare emissions, such as like life cycle assessment of ammunition production or military equipment production, but also improved methods of tracking the damage and different sources of GNG emissions, such as the like emissions from fires at oil depots or like leakages from oil production or gas production facilities. But also, I would say that there is the potential to improve activity data collection, because if there will be a clear demand for this data, the state could significantly improve those data, because some data are available for relevant authorities, but they are just too sensitive to be disclosed during the wartime. Thanks.
Thank you, Mr. Mikola. You made a great presentation and provided us with important insights, how it's compelling to find a reliable source of data during the wartime for the warfare activities, and how it's hard to gather data. I would like to invite to our panel our second speaker, Dr. Swіtlана Краківська, who will cover the landscape fires for today. Ms. Swіtlana, as we saw on the previous slides, GHG emissions from the landscape fires take the third place on the basis of their amount. How they are measured and how they are attributed to the war.
Well, thank you for this question. It's actually a difficult question, and that's what we were doing when we tried to attribute. So next slide, please. Okay, so we have landscape fires, and it's clear that if we speak about war fire, it's definitely can be attributed to the war. When we speak about landscape fires, someone could say it could happen without the war. So this is the problem, in fact, which we wanted to solve. And here's a map produced by our co-authors as well, where it's visually clear, actually, that fires is at the front line. So it's qualitatively it's like this, but our task was to quantify how much emissions actually those fires produce in the atmosphere. So next slide, please. And we start with the definition, where we actually speak what is landscape fire. So it's about human-related It could be prescribed managed fires, which is now banned by law in Ukraine, at least, and it could be wildfires, and how it looks right now in Ukraine. So next slide. And our main steps, we had these four main steps. So my task was on the fourth step, but I will shortly introduce all previous. So first, it's mapping of fires. We use this kind of map in QGIS with my actually supporter and co-author Lydia Kristap. So we use this kind of map divided on grids with 50 kilometers actually size, and then we go next. So we actually took those next please, So we took those fires from this regional Eastern European Fire Monitoring Center. So they provided us with all actually areas, all perimeters of fires, which were manually done by trained photo interpreters who analyzed the Sentinel-2 mosaic with 1 kilometer radius of this hotspot, obtained from MODI satellite sensors. Next slide, is it okay? Next slide, you see the example actually how it looked when those people made it. So they had these perimeters of fires, and they knew how much inside different land use was inside. So it's actually different. You see, it's different kind of land use, which when burned actually emitted different kind of different amount of greenhouse gases. So next. Step two, so we had these fires, we had these perimeters, we had this area of burnt territory, let's say, but we need to identify zones where we will attribute. So zone one, we call it like government control territory, which is not impacted, and it's outside this zone two, which is accumulated 30-kilometer buffer zone on both sides of the front line. And we identify zone three, which was occupied before the full-scale invasion. In this, our study, we didn't use it yet, let's say. And next slide. Within those zones, again, we identified those perimeters, and within every perimeter of fire, we had different land use, like forest fires, cropland fires, and for every this land use, those experts, they had actually previous data, what kind of forest was on this part of territory, so they can actually estimate, is it young, middle-aged, premature, or over-mature forest, which again, depending on it, how much emissions will go when it will burn. So again, for cropland fires, used statistical data, because we know that our actually relation of different crops like this, so it's the main crops like wheat, barley, sunflower, and corn. And when we had this territory, so again, this kind of estimation were used. Next. For yields and volume of crop biomass, again, so statistical data were used for this, and again, amount of biomass was determined using coefficient of the total yield, and again, it's root residuals of crops depending on the main product's yield. So it is statistically actually known from the previous research in Ukraine. In other natural landscapes, actually, so they include hayfields, fallows, and pastures. Again, it is based on statistical data and numerous botanical and ecological research. It was grouped by Ukraine's natural zones. Next. So then we go to this step where actually my group, let's say, was responsible for. In this case, what we call attribution, in fact. So attribution we call, so it's the act when we can attribute and quantify this. In this case, it's about fires, about emissions, to military actions in this total area. First, we wanted actually to use historical methods, how it used, how in attribution study it's usually used for climate events. So you know from the past that such kind of event, such intensity or such frequency you had in past. In this case, it was not possible. In fact, because we didn't have so long data in the past, and we didn't have such good data for fires. As I said, it's 1 kilometer resolution, in fact. So we start to have this data only from 2022. And we know that previous actually years before 2022, it was very dry years. So it was not possible again to use this historical data. That's why actually we start to use another data, another approach, which we call it like spatial relation. So we knew that in this accumulated 30-kilometer buffer zone, and we compare with government controlled territory for 4 land use types, 4 calendar seasons, and 5 types of fire weather index. So we include here actually weather, which is one of the main, actually could be one of the main cause of those fires. Next. Well, so our assumption, so this is the main assumption, that if we will not have war, identical weather conditions which defined by fire weather condition in the same season, in the same land cover, would result approximately equally comparable burnt area across Ukraine. It's clear here that it's not the case. So let's go next. About fire weather index. So this is really a very complex index, which actually incorporate weather condition now, let's say, in the previous, so it's daily moisture level in 2 centimeter deep. And actually this index based on 3 others, which this is first related to temperature, relative humidity, precipitation, and wind speed. Then another index which incorporated in this index, it's about 2 weeks conditions, previous 2 weeks conditions, and another it's drought code, which is about previous 2 months. So it's really very complex and can estimate how much you have fuel for future fire. Is it wet or is it dry? So it's really one of, on our opinion, best approach how to do it. We took this fire weather index, daily fire weather index from Copernicus data center, so it's freely available, and we attributed it to these perimeters of fires. Next. So after all, we have 4 different land use. So one of them is this coniferous forest. We have and deciduous forest. So it's clear here where actually it's located, and then we have fires in those land use, and the same, we made the same territory in the controls, and we made their relation. So this is the main approach. And then next, please. So here it's summer for 3rd year and spring for 3rd year. So after all, we have such kind of attribution coefficient for every fire weather index, which can be low, moderate, high, very high, and extreme. So it's 5 here, 5 those bars. And it's clear for different these 4 types we used that they almost 100%. So it's only here, let's say, in summer for low fire weather index, just maybe because it was not in this very hot part of Ukraine, let's say. So it definitely could be somewhere in another place. So this is approach how we made it, and I want to bring another point in the next slide, where we have actually cropland, and we have other. So for cropland, which actually covers 70% of the territory of Ukraine, we have a very different situation in autumn, for example, because in autumn we have actually negative coefficient. What does it mean? It means that, especially for low fire weather index, it means that our farmers, when it is wet weather and low fire weather index, they just burn residuals. And this is fires in controlled territory, which actually more than fires in the buffer zone. So it means that actually approach works. So this is actually just to explain how it works. And for winter, where in this third winter we had pretty wet winter, that's why we have only low fire weather index, and this coefficients for different land use, they are, you see how they actually look. Okay, and next. So after all, when we have this attribution, so we have actually area of fires all, let's say, and all in buffer zone. And then we attributed them with those coefficients we made in the previous step. And these factors, if we aggregate it, so you see that the biggest actually is for coniferous forests. Well, but in actually mean is almost 90%, 88%. And then next, so after we have this coefficient, we can apply them actually for emissions. And if we go for emissions here, so we can attribute again this we see in zone 1, in zone 2. So again, zone 2 it's zone with war actually, and it's again what is clear from here that for year 3, where we had much drier conditions than in the previous years, we have much more emissions as well. So much more fires and much more emissions. So it's actually the same as in the previous 2 years, and this is the total numbers. And next. So here's like visual how we can actually how we estimate all those emissions which goes to atmosphere from this military action in landscape, and it's not only direct emissions again. So this is emissions which on losses of the carbon sequestration capacity of the forest again. So and it's different land use, which can emit different different amount of emissions as well. So this is our approach. We hope to publish it in peer review journal soon. And this is for 2 years, and it shows. So it's almost 4 years now, but we still under review this publication of 2 years. So this is just demonstrate how thorough actually this review process is. Next. So after all, this is numbers. I say this tell a story. What kind of stories they tell? Again, what I said. So emissions from landscape fires, which were in the first and the second year, which were wet here, they actually the same as we had in the third year, unfortunately. So the weather promote these more fires, and especially in this war zone, ignition due to war fire. So in this case, we have much more emissions as well. And the most goes from forest, in fact, in this war zone, and less in croplands and other vegetation. Actually, it's really very difficult to do agriculture in buffer zone. I mean, it's actually not there. It's former cropland there. And the next. I just want to put connection because this kind of story I told at the NATO Climate Security Summit very recently, and this report I showed together with this map, which Ukrainians pretty aware about what kind of what kind of flying apparatus we have in Ukraine, because sometimes abroad people ask us Ukrainians, do you have direct flight from Ukraine? And then I just show them what kind of flights we have over Ukraine, and actually they go to directly to the West Europe. So thank you.
Thank you, Ms. Svetlana, for explaining such a hard topic for us. And we see how complex it is to calculate the landscape fires with all the indicators, with all the factors, and a specific attention you brought to how weather conditions, how drought amplifies the landscape fires and contributes to additional GHG emissions. Thank you for that. And I will invite last but not least speaker, Mr. Leonard de Klerk. Mr. Leonard, we see a lot of cities with growing emissions as to the civil aviation sector and to the reconstruction sector. What are the methodologies you are using? What are the predictions? And how these methodologies been detailed, developed through the years? What do you see and what can you tell us?
Yeah. Yes, thank you very much. Indeed, I will be talking about two impact categories. One is aviation, and the second one is the emissions from the future post-war reconstruction of Ukraine. I'll start with aviation, and actually, aviation is a typical example of an indirect impact of the war, because we're not talking about emissions in Ukraine itself, but it's deviations of flights that cannot take the direct route as they used to do. And actually, here I'm showing 5 different impacts of flights in the world, actually. It starts with, which has the biggest impact, is flights between, particularly in Northern Europe and Asia, because normally the direct route would be over Siberian airspace, but Russia has closed the flights from unfriendly countries, as they call it. So from Western airlines, they're not allowed to use over Russia anymore, including the Siberian airspace, and they have to find a different route. And I'll show you later how that different route looks like. No, just back. The second one is between North America and Asia. There are certain flights that fly over Kamchatka. So if it's a North American airline, unfriendly country, it has to take a detour. No problem. But it also works the other way around, because Europe also has closed the airspace to Russian airlines. So between Kaliningrad and the Russian mainland, they used to fly over Lithuania, which is now not possible anymore, but also a bit of an exotic flight that's between Moscow and Cuba. Fourth category is flights between Eastern Europe that have to circumvent the Ukrainian airspace, because obviously it's not safe to fly over Ukraine. That also applies, that's category number 5. That's for flights that are in the southwest of Russia, close to the border with Ukraine, because that's now a war zone as well. So they have to avoid it. Next slide, please. But we were just struggling on how do you quantify then the actual, increase of kerosene in order to calculate the increase of CO2 emissions. We only did this very recently. In our latest report, we managed to fully update our methodology, which is presented over here. And we got from Flight Radar 24 a database of all flights in the world for 1 week before the invasion and 1 week, the same week in the same month after the invasion. And these were huge databases, because for each of these 100,000 daily flights, we got the information on the GPS coordinates of a plane every 5 minutes. And you just can imagine the amount of data we're talking about. So we really had to evolve a data expert in order to process all that data. Then we selected only those flights that flew over Russia, Belarus, and Ukraine pre-invasion. And then we tried to find in the post-invasion database that same flight, and then see what new route they had to take. And then based on the International Civil Aviation Organization, they have a standardized methodology to calculate CO2 emissions for each type of planes, because we're also talking about different type of planes, of course, that you have to take into account. And this is how we calculated CO2 emissions. Next one, please. And just here, I'm just showing you a couple of examples. So first of all, London, Tokyo used to be almost a 12 hours flight going over Siberia. Now they have to fly over northern Canada, significantly increasing the flight duration of, with 3 hours to almost 15 hours. The other one, which a bit of a surprise, but that's between Anchorage and Zhengzhou in China. They used to fly over Russia, not possible, again, taking a detour. Next one. Here is Kaliningrad. They really have to take now a huge detour over the Baltic Sea in order to avoid European airspace. And here you can see an example of flight between Minsk and Antalya. They were not, this is probably Belarusian airline, because already before the full-scale invasion, a Belarusian airline was not allowed to fly over Ukraine, but that was because of sanctions from the Ukrainian side. But now they even have to fly even further around Ukraine to avoid particularly this zone, which is also dangerous to fly over. Next slide, please. And then, yeah, this bit of an outlier. It's Moscow, Kayakoko. To really project it on a globe to see it, but this is almost, a straight line. And now they first have to go to Murmansk, avoid Iceland, and then they can fly to Cuba. This doesn't have a big impact on the numbers, actually, because there are not that many flights. Like I said, the impact also in CO2 is the Northern Europe, Asia flights that cannot use Siberian airspace. Next slide, please. So that's about aviation, and actually we're talking about 230 to 240,000 flights per year that are impacted by these impacts. Then reconstruction. So first of all, we're talking about mainly future emissions, because it's about the emissions that will be generated when Ukraine will start to rebuild everything what was damaged and destroyed. Of course, Ukraine has already started reconstruction, and particularly in those areas that were liberated by the Ukrainian army. So we're talking about part of Kherson, north of Kiev, and also parts of Kharkiv. But of course, the bulk of the reconstruction still has to happen. And the way we've managed to estimate these emissions is basically on we use data from the Kiev School of Economics. The Kiev School of Economics is collecting all the information on what has been destroyed or damaged from schools, apartment buildings, roads, amount of trucks, for example, that have been destroyed. And we've used that input to calculate emissions using two ways or emission factors. First of all, if we had the life cycle emissions assessment of the particular object, we use it for the emissions. So it was either for a building expressed in a square meter or per unit. For example, how much does it cost? What are the emissions to build a new car, for example? These factors were not available for all kind of destruction. So where it was not available, we used the so-called environmental extended input-output, which is expressed in kilograms of CO2 equivalent per US dollar. Because the Kyiv School of Economics also provided information that how much would it cost to rebuild it, and then basically we could use that for the emission calculation. Next slide, please. And here just show you an overview, but these are, for example, emission factors for buildings. This is based actually on a Finnish software that has a database of recently designed buildings in Central and Eastern Europe, and these are average factors. So if you would use standard building construction technologies, you know how much kilogram CO2 equivalent you would have in constructing this. Yes, it's blind. But also here you see modes of transport, trolleybuses, fire trucks, and on the left down you see these extended input-output factors for different type of activities like constructing a bridge, or for example, if we have electronic equipment, but also rebuilding airplanes that were destroyed. Yep, next one. And actually here you can see why these reconstruction emissions are so high, because for a typical building, here you can see the emissions of constructing, and about 75 to 80% of buildings, it is concrete and steel. And we all know that these construction materials are very carbon intensive. That's why these emissions are so high. Next one. And here you see a breakdown over the 3 years. And it's very clear that the majority of the destruction happened in the first year of the war, because that's where the moment, you know, the front line was moving hence and forth. In the second and the third year, basically the conflict not got frozen, but the front line hardly moved. So unfortunately, everything that could have been damaged or destroyed was already damaged and destroyed in the first year. And therefore you see that relatively in the second and third year, the reconstruction emissions will be fairly low. Although you see industry and utilities, that's because of the Russians that are targeting utilities, continue to target utilities. So to rebuild what has been destroyed is still relatively high in the second and third year. So that brings me to the end, and actually, yeah, you see in the cover page, which I think very clearly also shows the impact of this war on aviation. So thank you very much.
Thank you, Mr. Leonard, for all your work and support of Ukraine. And as we see, the closure of airspaces is something that is not occurring as a consequence on the territory of Ukraine because of war, but is occurring abroad and contributes to the climate crisis as well. And as to the reconstruction, it's very important for Ukraine to develop the policies and action plans which can enable the decrease of the GHG emissions during the phase of the reconstruction. I'd like to invite all the panelists for the Q&A session. And I also invite the audience to ask every question you wanted to, but didn't have the chance while reading the reports. So please. Well, since the audience is gathering their courage to ask the question, I'll take this moment to invite you to our next side event, official side event, which will take place on the 18th of November and it will also relate to the climate damage. But the main focus of that event would be on the accountability and the ways to push accountability for Russia for the climate damage as an aggressor, and get the responsible party to pay what it is, what should be paid for Ukraine and damage to climate. And we already have the question. Yes.
I have a question to Svetlana. Are there any estimates? How much will it take to restore the forest? How many years to the capacity? And then again, it's like to the capacity that it was before the war, I guess. How would you estimate that it was restored?
Well, actually, it was not in our part of our work, and as far as I remember, here was the head of this forestry agency, and he presented different programs about restoration of the burnt and destroyed forest, and actually nature, and so I cannot answer this question as climatologist, but of course it's definitely. So I estimated decades, at least.
Maybe I can add on this because basically, what we're doing up till now is simply, accounting for emissions. And of course, we will continue to do it, but we will, we want to bring it to the next level. And the next level is, first of all, this accountability, so holding the aggressor accountable. But what the work that we are doing is also helping in understanding what we need to do to restore what has been damaged. So that relates to forests, but it also relates to the reconstruction, because the reconstruction is a sort of business as usual scenario that we've taken. But we know there is a lot of discussion already going on. I'm really impressed that despite the war, there are so many conferences and brilliant ideas and even pilot projects on doing a low carbon, green, build that better, whatever you would call it, but doing it more smarter than it was done in the previous times when Ukraine was still part of the Soviet Union. And of course, we do hope that this green reconstruction will also avoid some of these future emissions to happen, but therefore you also need additional funding, and then you come back to the accountability. So that is actually what our focus is on now. How can we repair some of the damage or avoid some of these emissions to happen during the reconstruction?
You can hear me then? Okay. This is Professor Lee from Taiwan. And I'm so glad I'm here because the people in Taiwan are so afraid of our international status. We feel like, eventually one of the days that we are going to be like Ukraine. So I'm from the background of international relations and law. So I'm really concerned, and the climate change. So I'm really concerned about the war emissions. And then I'm just wondering, is this particular report available, say, online? And then I do know some scholars back home that we are really interested in this topic. But then you will be the contact or the focal point. And I'll be very much happy to contact you and then, to be associated with what you're doing. And I thank you so much.
Thank you very much, first of all, for the whole presentations. I know about the report, but it was really interesting to know the details. I have two questions. One is, on your opinion, if it's feasible to use the methodologies and expand the report on trying to account for the damage caused since the beginning of the war, since 2014. Is it feasible? Is it necessary? Because there definitely will be some, not such a big impact, but yeah. And the second question is, also, do you think it's possible to try to account the destruction of soils? Because we know that the plowing of soils cause the CO2 emissions, and we know how big is the impact of war on soils. There is a picture right here. How Ukrainian land is look like now? So do you think it's possible to count it? So two of them.
Well, I should say that it will be good actually to extend this report back from the beginning actually of invasion but again we need data, so we need satellite data, we need data on fires. In principle it's possible, but need more effort, let's say. And of course, it will be less than after the full-scale invasion, but in fact, it's possible. So methodology, we tested. We tested on first, second, third, and now we are in the process of the fourth year. So it actually improves because we learn a lot. So every year we learn. Unfortunately, it's very bitter lessons, I would say. About soil, it's a very difficult question, but I know that people and scientists work on it as well. And I remember our first actually pavilion, Ukrainian pavilion with soil, which was so, it was something, in fact, just to present, because soil is our, like, in heart of our country. So I know people, I know that they're doing this work. I know their publication again, and I believe it's possible and even needed, in fact, to do, because again, soil is our treasure.
Just to add on soil, so maybe this is like a big problem, but I would say it's more about the environmental consequences and environmental pollution to the soils rather than like direct GNG emissions, because there are also like abandoned soils, like abandoned land on which vegetation is evolving. So it's like changing the like balance and carbon storage. But with respect to pollution with different chemicals, also mining of soils, so it's much more significant concern. And for historical emissions, yeah, it's also for some categories maybe it would be possible, but for some impact categories it would be very complicated because of like growing uncertainty of the data and lack of data for some activity data.
Are there any other questions?
I'm struggling how to frame it, but can you hear me?
Yes.
I was thinking since it's very impressive work, and from what I understand from Svetlana's point of view, I was just wondering if it's got to this level where it is like, if it's in order to file for the compensation, do we need to build the wider coalitions with well-esteemed institutions to level it up, and on an international level? But then again, like from Ukrainian side, what kind of a support should the initiative obtain from the government, from the state, in order to have a voice at the international arena?
So basically what we, you know, what what we are going to use is the international compensation mechanism has already been established as a result of the resolution of the General Assembly of the UN, where environmental damage isn't recognized, category as damages. So as such, there is no a political support needed because it's already there, the mechanism. It is just a matter of bringing in carbon emissions in that claim process. And there, it's the first time, and this will be the first time that a country is going to be held responsible for greenhouse gas emissions as a result of an unlawful act, the act of aggression in this case. So from a legal perspective, there are still, some questions that have to be answered, and who should be compensated, how should be compensated. But this will definitely be also learning by doing, because Ukraine would be the first, but Ukraine is also the first in many aspects. The fact that Ukraine is recording and documenting environmental damage in itself is already a first, because in previous conflicts, whether that was in Yugoslavia or in other parts outside of Europe, it has never been done before. So I'm convinced that we will get there. But there are still questions, that needs to be answered on exactly how to do it. But I can't go too much details because that's for Tuesday. But we do have a concrete plan how to do it.
Thank you for all the questions and answers. While you are still thinking whether you have another question, I'd like to just quickly reflect on the comment of Professor Lee. I think if I get your name correctly, we will of course share the report with you. It's available online. We have flyers with information which can be of use. And unless there is
maybe just one remark is that, basically when we started this work, we realized, it's never been done before. But we also realized that conflict emissions is an enormous gap in the carbon accounting. It's not being discussed here. It's being discussed by us, by civil society in side events, but it's not part of the main program. The same applies to military missions. And military missions, I mean, the emissions that the military and military industry emits during peacetime, so when not at war. So this work, actually, what we've been doing has triggered a whole new discussion. We started at 3 years ago. Now we have several side events on military missions. We have more publications and so on, and we really do want to bring it also to the, to the real negotiations, because that's where it's currently still lacking.
If I may actually to add, because at the beginning it was not clear, and maybe even now not from all clear how actually this Russo-Ukrainian war can impact climate. But with this research, with this report, we show clear how, because we have our common carbon budget and we exhaust it for this war. And so it's actually impact for all, not only in countries which are in the war, but really global impact. And just answering about this forest which actually destroyed, and nature which actually destroyed, we had here a film documentary on destroyed nature and our environment, and it just brings to me how Michael Mann answered Bill Gates. He said, you cannot reboot already crashed planet. So if we destroy nature, we will destroy our environment, we will destroy ourselves. So this is what we need to promote more and more on every place where we can, in fact. Thank you.
Thank you for your additional reflections. And I would like to add that it's indeed a unique and very innovative approach of accountability and accounting. And we still don't have all the answers because, again, it's something new. And I hope we will figure it out in the process. And what we are doing right now, we are pushing for change. And we will see the results of that change, I hope soon. Thank you all for your attention. A lot of gratitude to our distinguished speakers. Again, we are inviting you for our next event on 18th of November. And I encourage you to have additional discussions with the authors outside of this event. Thank you.